Today we're going to talk about periodic graphs and intro to graphing sine and cosine. So a periodic function is any function that repeats values on regular intervals or periods, thinking about your breathing, your heartbeat, waves of the ocean, something like your birthday repeats once a year, that's periodic. These phenomenon repeat the same activity as a steady pattern. The most famous periodic functions are the trigonometric functions, which is what we're looking at, sine and cosine. Other examples of periodic functions in nature include light waves, sound waves, and phases of the moon. So a periodic function is any function that repeats a pattern of y values at regular intervals. One complete cycle is one complete pattern of y values for a periodic function. The period is the horizontal length of one cycle before it starts to repeat. And the amplitude is half the distance between the max and min values of the function. So looking at this graph right here, you can see that this has a horizontal distance that it repeats. So what does that mean? It means that if I draw over this part of my graph right here, and then I take it, I can move it over and it makes the same graph. And I can move it over and it makes the same graph again. That's the horizontal distance that it's repeating. So the smallest part is where it stops. So before it starts to repeat, what is that distance? That distance tells you one cycle or the period. So you can see here it's highlighted in pink. Do you have to make it go like this? No. If I make it go like this with this like little zigzag here, that also repeats. Consider a period, and you can just measure that length. So you can see from here to here, the distance is 1, 2, 3, 4. So the period of this would be 4. So same thing here. If you go from here and count 1, 2, 3, 4, that's a distance of 4. So that's one cycle. So you don't necessarily have to start at the same spot, but you stop where before it starts to repeat, before the graph starts to repeat itself. So it says determine if the graphs below are periodic. If they are periodic, determine the period. So remember, we have to have a horizontal distance that we're repeating. So if I look at this graph here, it looks like the graph is making this kind of, maybe let me use a better color here. It's making this kind of shape right here, right? So if I take that shape, it looks like it moves down. Let's see, now look at that overlaps right there. So maybe not even, sorry, not that shape. So we don't want the whole zigzag. We just want just kind of this like L shape. And if I keep moving that, whoopsies, where did it go? This would move here, right? And this would move here, and this would move here. But you have to be careful. We're not moving in a horizontal direction. This is moving vertically, right? So it moves down. So this is not periodic. Okay, so let's look at the next graph. We want a horizontal distance that repeats. So it looks like the graph is repeating maybe this pattern here. So if we move that over, it would match up here, and it just doesn't have the full graph. So if you look on the other side of that, this matches up with the part that wasn't there. So that tells me this has a horizontal distance, because see, I'm moving it horizontally, not vertically, to get the next pattern. So this is periodic. And what is the period? So now we want to figure out what that distance is before it starts to repeat the graph. So you have to be careful on this one, because it looks like the scale is going by 2. So this is 2, 4, 6, 8. So it stops here, and it looks like it's in between. So that looks like this is at 7, and it's starting at 0. So that means that the period is 7. Looking at the next graph here, it looks like the graph has this kind of, if you want to go like this shape here, you could say before it starts to repeat, to make it a little bit easier, and then you can see the distance from here to here. Or really, so if that's repeating, then you can kind of say it's going from here to here. We'll kind of use whatever works for you. So let's say I just used this distance here. So what is that distance? Again, the scale is by 2, so this is -2, -4. So it's going from -4 and then all the way to here, which is at +4. So that's a distance of 4 and then 4. So the period is then 8. So yes, periodic. And the period is equal to 8. So looking at this next one, it looks like this shape right here is being repeated, but it's not being repeated in a horizontal distance. It's being repeated kind of vertically, so because it goes up instead of straight across like this. If it was horizontal, the next shape would have been here, and then here, and then here, right? So this is not periodic, so no, or not periodic. If it's not periodic, then you can't find the period. So next looks like it's graphing the most famous ones that we have, the trigonometric ones, graphing sine and cosine. So the graphs of sine and cosine are periodic. We have learned that the sine value of the function is equal to the y value, and that at that corresponding point angle in the unit circle, and the cosine is equal to the x value at the same point on the angle. So these graphs of sine and cosine look like waves, and they're called sinusoidal. It's just a fancy word for trig graph. So if you see the word sinusoidal, it just means trig, sine or cosine. It says to sketch the basic graph of sine by hand, it helps to note the 5 key points in one period. The key points are the maximums, minimums, and intercepts, or where the graph crosses the midline if we have transformations on the graph. To find the key points, you divide the period of the function into 4 equal parts. So the period divided by 4 tells me the key points. So the sine and cosine period is one time around the circle, which is 2 pi. So this would be 2 pi over 4, which is pi over 2. So that would be for sine and cosine, the key points. So looking at this first one we have right here, if we're thinking about the unit circle, which we already have, the sine is the y coordinate on the circle. So starting at 0, we have 0 at pi over 2, because remember this is pi over 2, pi, 3 pi over 2, and this goes all the way back around to 2 pi, so just repeats. So at pi, we have negative 1, we're looking at the y coordinate 0, negative 1, and then back to 0. So notice it's going to repeat itself. So for the sine graph, it starts at 0. At pi over 2, we have 1. So if you want to use 1 here, you can, or if you want to skip a line to make it a little bit higher, I'm going to do that. So I don't have to write over these. So I have pi over 2, 1, then pi 0, negative 1, 0. And that would be the first wavelength of my graph. And so this graph is going to repeat itself. So those values would keep on repeating if we were to continue. So over here for cosine, cosine is the x coordinate on the graph. So the x coordinate would be 1, 0, negative 1, 0, 1. So this would be 1, 0, negative 1, 0, 1. Again, I'm going to skip a line. So 0, it starts at 1, then goes to 0 at pi over 2. Pi is negative 1, 0, and then 1. So my graph would look something like this. You can see for both the graphs, the maximum or the highest we go is 1. So this is, of course, a maximum. And the same thing, it repeats, so it's going to have more than 1 sometimes. So maximum is 1. The minimum is the lowest we go, which is negative 1. These graphs, you can go around the circle as many times as you want, so the domain's all real numbers, but the range is going to be from negative 1 to 1. The midline is the middle of the graph, so if we look at this graph here, you can see it looks like the middle of the graph between the max and the min would be here, and so that's called the midline. And that is, we say y equals 0, it's a horizontal line. And then the amplitude is going to be the distance from the midline to the max and min. So this distance here is what we call the amplitude, or here, that's the amplitude. So in this case, if you count up 1 or, up 1 or down 1, that's the amplitude. So the general equation for sine or cosine is a times the sine of x plus k. Notice that k is not inside the angle here, so if it doesn't have parentheses, same thing, it's on the outside. So with this, that absolute value of a is the amplitude. If a is less than 0, it reflects the graph across the x-axis, and y equals k is the midline. Sine graphs start on the midline on the y-axis, which is important. So sine starts on the midline on the y-axis, and cosine graph starts at the max or min value on the y-axis. So let's go ahead and use Desmos to graph. So we're going to kind of follow these steps and go along. So you can look at this as we are looking at Desmos. So here we are in Desmos. We want to graph this graph that we have right here, 4 sine x minus 1. So the first thing you're going to do is type this in. 4, if you have your keyboard, you can just type in sin. It's not sin, it stands for sine. Go to your functions and hit sine, and then x. Make sure you close that parentheses because that negative 1's not inside there, so minus 1. So here is my graph. In this unit, we're switching back between radians and degrees. So when you click on that wrench, you always want to make sure for graphing that we're in radians, but when we're doing the right triangle trig, you want to make sure you're in degrees. So for this one, we're going to make sure we're in radians. So we plug the equation in, and then we're going to put the midline on the equation. So in this case, we have to find the midline. So this is our A value. Let's see, change that. So this is A, and this is our K. So the amplitude is the absolute value of A, which is 4, and the midline is y equals k, so negative 1. So on here, we're going to write y equals negative 1, because that gives me the midline graph. And you can notice then if you count up and down from this midline to the max and min, that gives you the distance of the amplitude. So I can count from here up 1, 2, 3, 4, or from the midline down 1, 2, 3, 4. So it tells us again what the max and min values are. Something that's nice about this Desmos is that you can change the x-axis so it matches what you want. So you can kind of match it to your graph, or usually what I do is I just put negative 2 pi into 2 pi here. And then nice thing about this is you can even change the key points, but if you don't, that's okay. So if I'm looking at my graph here in Desmos, move this over slightly, I'm looking from negative 2 pi to 2 pi. So when I'm graphing this, on my graph, the period for these, since we're not changing them right now, we'll change them in the next lesson, is just 2 pi, one time around our circle. The key points then would be the period divided by 4, which is pi over 2. So if you know that, you can actually change the theta step here and type in pi divided by 2. And you'll notice what happened when I did that on my graph. It actually gives you the values that you want for your x-axis. Because when I'm graphing this on my graph from Desmos, I'm not going to skip those values. You see this has 1, 2, 3, 4 lines before I get to pi over 2. I'm not gonna skip and do 1, 2, 3, 4 and write pi over 2 here and then have 0 be here and pi over 2, and it looks like the values at pi over 2, 3. I'm not going to graph my graph like this, because then I'm not going to be able to graph, because it wants us to graph a minimum of 2 cycles on each graph. So if I graph and leave all those points in between, I'm not going to be able to get 2 cycles on my graph. So instead, what we're going to do is we're going to graph our midline first, which is here. So that's the midline at y equals negative 1, which we already have that black line on our graph. That's the midline. So then we're just going to kind of follow this. So if I follow this over, then it starts at let's start at the y-axis. We're starting at 0, negative 1. So 0, negative 1 is right here. Then the next point we have is pi over 2 and 3, because we're graphing just where it crosses the midline in the maximums and the minimums. So the next place that hits is pi over 2, 3. So instead of skipping over these 1, 2, 3, 4 lines, I'm going to write pi over 2 here on the x-axis, and then I'm going up 3. So I'm going to put it right here, pi over 2, and then up 3 we go here. So my graph goes to there. Then the next point that it hits is on the midline. So you're not using the zeros there, so just ignore the zeros. We want to hit where it hits the midline. So the key points are the maximum, midline, maximum, minimums, and the midline. So it hits at pi negative 1. So then we're going to put pi here and negative 1. Then if we keep going, the next point is 3 pi over 2 negative 5. And then the last point would be here at 2 pi negative 1. So that gives me one cycle. So you can see then if I make this a little bit bigger, let's see if I can move this over. You can see then the distance from here to here is your amplitude. So that's 1, 2, 3, 4. So that's the amplitude. One cycle goes from here to here. So this is one wave, which is your period, so 2 pi. The key points are going by pi over 2. And then the domain would be negative infinity to infinity. And the range now, the lowest number we have is at negative 5. And it goes all the way up to 3. So that is the range. Well, another issue we have is that we did from negative 2 pi to 2 pi on our Desmos, but I don't have all the way over there. So I have just 2 marks over here. So I can go backwards a minimum and where it hits the midline. So negative pi over 2. And that would then be at negative 5. And then the next one would be negative pi and negative 1. So my graph would go like this, but that doesn't give me a full cycle. So then I need to go the other direction. So what you could do is change this wrench, or you can just, hit over on your graph. So we stopped at 2 pi, which is right here. So the next point would be at 5 pi over 2, 3, 3 pi negative 1. So this would be, you write your x coordinate on the x-axis, and 3. Then we have 2 pi, or sorry, not 2 pi, 3 pi negative 1. So that would give me 2 cycles because I have the negative part right there, but I'm just going to keep on going. So then 7 pi over 2 is negative 5. And if we go all the way across, 2 cycles, if one cycle is 2 pi, then 2 pi plus 2 pi is 4 pi. That would give me another cycle. So now we've graphed 2.5 cycles here. So this would be wave 2. And this was a half of a wave on the other side. So we only needed 2 cycles, but not bad to graph more. All right, so let's go ahead and practice another one. So I'm going to clear that out. And I'm going to type in the equation negative 3 cosine now. So you can hit the functions of cosine, or you can just type it x, close that parenthesis, plus 2. So here's my graph. We need the midline. So the amplitude is, again, that a value in front. So the absolute value is a distance. The k value here is going to be the midline, so y equals 2. So if I draw that on my graph, your graph should go up and down from this line. That's why we always like to draw it on the graph. So on here, if we type in, so notice you can get the maximum and the minimum, but you don't know where that middle point is unless you graph the midline. So we are going to type in y equals 2. And so on my graph, let's start at the y-axis. So this point right here would be 0, negative 1, pi over 2, 2, pi over 5, pi 5, and then 3 pi over 2 is here, and 2 pi. So that would be one wavelength. That's 1, 2, 3, 4, 5 key points in one wavelength. So you just got to label your x-axis with these x coordinates. So pi over 2, pi, 3 pi over 2, and 2 pi would be one wave. So then if we graph this, we start at 0 and negative 1, because this is the amplitude distance. If you count down from the midline, 1, 2, 3, it starts here. Then at pi over 2, we have the midline 2. Pi, if you count up from the midline, 1, 2, 3, notice that was why we have pi 5, back to the midline, and then down. So this just comes from plotting those points. So then I'm going to scroll over so I can see more of the points. So this was the one we just did at the 2 pi negative 1. Again, you don't want the zeros on the graph, so I'm not going to graph this decimal point right here. I'm going to use this point at the midline, maximum, midline, minimum, not the zeros. That's the x-axis. That's kind of a little bit darker. So we just need to write down those values. We have 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So 5 pi over 2 is the next one. Then 3 pi, 7 pi over 2, and 4 pi. So if we keep going, then this would be back here at midline, up the amplitude 3, back to the midline, and down 3. So again, just notice we're always going back and forth between this midline. And if we wanted to do negative values, those are just going to repeat. We could go in this direction as well and do the negatives. So the period's still 2 pi. The key points are still 2 pi over 4, which is pi over 2. Domains all real numbers. And now our range changed from -1, and the highest value we have is 5. So from -1 to 5. All right, and then this right here, from here to here, is the first wave, and this is the second wave. Okay. All right, so let's do the next one. So the next one's also a cosine. So again, I'm just going to take this 3 out and plug in 2, and then we have -4. And then so the amplitude is 2, the midline's y equals -4. All right, so on my graph, I'm going to go back to the y-axis. So here's my y-axis. It's that line that's highlighted. This is the x-axis. We're not crossing that this time. So here's the maximum, midline, minimum. So again, let's do it again. Maximum, midline, minimum, midline, and then I can't get the maximum because it's just too close together, so I'll do it in a second. So we're starting at the midline, which is at -4 here. We'll put that down. So we're starting at 0, -2, because again, that's up 2 from the midline, back to the midline. So that's at pi over 2. And we have pi -6, because that makes sense because you're going down 2 from the midline. Then the next point we have is 3 pi over 2 at the midline. And then the next point would be 2 pi and at the maximum, so up 2 from the midline. That's one wave. So again, here you couldn't see it before, but there it is, 2 pi -2. And then notice the next one's going to be at 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So 5 pi over 2, and yes, I do want you to label these. 7 pi over 2, or no, sorry, I missed 3 pi, 3 pi, 7 pi over 2, and 4 pi. So we have 0, -1, 0, 1. You're just plotting those points. So that's your second cycle. And if you wanted to go backwards, you just do the opposite. So the period's still 2 pi. The key points are still pi over 2. The domain's still all real numbers. It's always going to be all real numbers for these. And the range is what's changing. It's from -6 to -2. All right, there has one left. So you could try pausing the video and unpausing when you're done to see if you get it correct. So this one we have negative sine +3. And then, so my amplitude is the absolute value of -1. So there's nothing there. It's 1, which is just 1. My midline is this k value, so y equals 3. I'm just going to draw the midline on my graph because I know, again, my graph should look like it's going up and down from that line. Period still 2 pi. Key points are still pi over 2. The domain's going to be all real numbers. So on my graph, if I start at the y-axis, going back here, and I need my midline, so y equals 3. So it starts at 0, 3, then pi over 2, 2. So this would give me my first wavelength, those 5 points there. So again, 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 2 pi. So then for your graph, they have 0, 3, pi over 2, 2. Pi is back to the midline. 3 pi over 2 is up 1 from the midline because that's the amplitude, and back to the midline. So if you know where you're starting, you know you're just going up and down the amplitude. So we started here, but in this case, because it's negative, we're going down 1, up 1, back to the midline, up 1, down, back to the midline. And so then on our graph here, after 2 pi, the next key point for x is at 5 pi over 2, and then 3 pi, 7 pi over 2, and 4 pi. So we're going to add that to our x-axis. So 5 pi over 2, 7 pi over 2, 5 pi over 2, 3 pi, I said again, 7 pi over 2, and then this would be 4 pi. So we're just repeating those same values that we had before. So we're at the midline and it was coming from a maximum, so we have to go to the minimum, back to the midline, up to a maximum, back to the midline. And then so the range for this graph looks like it's from 2 to 4. Remember, when you're writing the domain and range, you always write in order from the number line least to greatest. So that's why I write the 2 before the 4, because 2 is a lower number than the 4. And that is it for graphing sine and cosine.